name is Rob Ambrose, the Vice President of the Industrial Activities Board at the ICRA Robotics and Automation Society. Today, we're going to have a focus on the construction industry. A presentation that has been facilitated in partnership with the Construction Industries Institute. First, I want to go over the agenda, show you a little bit about what we're going to be reviewing today. I'll have some opening remarks, also introduce the VP-elect, Andrea Kay. Then we'll turn it over to John Palmer for some opening remarks, and then we'll have 3 panel discussions that will be using pre-recorded presentations from brainstorming sessions that occurred a little over a year ago, focusing on some challenges in the construction industry where robotics and automation might be helpful. We'll then have questions after each of those, and then at the end, we'll have a little bit of time for any additional questions and wrap up. I also want to take a moment to announce the selection of the 2021 ICRA Award winner. We had 4 finalists, the Mirror 250, Infimon's picker system, the ABB Pixel Paint, and Micropsy AI guided manipulation. And we're happy to announce that we've selected the ABB Pixel Paint as this year's winner. We selected them for their innovations in the field of automated painting, providing more flexibility and customization with reduced wasted paint for the wellness of the environment. They are now added to a long list of other distinguished winners, including back in 2016 when ABB won for their collaborative dual arm robot. So ABB is a second-time winner in recent years. All right. Wanted to tell you a little bit about our collaboration strategy. We have a long tradition of working with sister robotics associations around the world, but our thought is to try something new, aligning with some non-robotic sectors that are more focused on industry and targeting some emerging markets that are facing some near-term disruptions. Our goal is to find partner associations and institutes in those sectors and engage with them and academia to look where robotics and automation technologies might be helpful as those markets emerge. Our goals are to help those industries and those markets by connecting them with the technology and researchers that are in the Robotics and Automation Society. And then for our point of view, also expand the Robotics and Automation Society's reach with engagement into these new industries that are just starting to embrace robotics and automation. Today, we're going to focus on the construction industry. After we did some brainstorming looking at different sectors, we saw this was one where lots of new products are coming out, and the safety implications, the costs, and the labor challenges in this industry all make it for emerging robotics and automation applications. Often you look at these pieces of equipment from a distance. If you squint, they kind of look like the existing equipment that we've had at construction sites for decades, but when you get close to them, you realize those are actually robots, and that is going to become more and more a fact. We're going to look at, well, first I want to introduce the Construction Industry Institute. Our approach is to find an association or an institute already in the industry and then work with them and form a partnership. So you're going to hear from them next. And John Palmer will tell you a little bit about CII. Today we're going to look at 3 challenges. A work site without cranes, where cranes are expensive and a choke point for a lot of material flow. What would a construction site look if you didn't have that? Also work sites without people, considering how people can be at the work site remotely, interacting with the construction or using robotics and automation on site. And then lastly, what would a work site look like if it didn't have weather constraints and all the costs and schedule uncertainty associated with weather and how we might make construction sites more resilient? Our format is to have a recorded brainstorming session followed by any questions that you have being answered live here in this session, and then we will have at the end a demographically diverse panel that will handle any final questions that you have. All right. I want to then turn it over to John Palmer for some opening remarks from CII.
Great, thank you. So greetings to everyone and welcome to the session. I'd like to thank Dr. Rob and the ICRA Industrial Forum for inviting us to speak about one of the methods that CII is using to create visions that advance the construction industry. So as Rob said, my name is John Palmer. I work with CII at the University of Texas at Austin. And if you're not familiar with us, we're a consortium of over 100 companies comprising contractors, owners, consultants, and technology service providers. These companies, they come together on a regular basis and focus on many aspects of the capital projects industry. The member companies will submit volunteers to work with us. We'll work on research projects, various initiatives, committees to socialize problems and ideas and best practices. So I would invite you to visit the website that Rob listed on his slide and learn a little bit more about what we're working on, and if you're interested, how you might get involved. The specific group that I work with focuses on technology and innovation, and we have a vision of both dealing with and assessing present conditions and the future state of the industry. Our present vision really focuses on a couple of areas. One is technologies and innovations that are in use around the world, both in the capital projects industry and other industries. And we'll look to see how we can apply those to what we're trying to accomplish. The other aspect of the present vision focuses on interoperability of current processes that are employed in the capital projects industry to essentially enhance efficiency of processes and procedures that are in place today. But today our focus is really on the future state of the industry. And this idea was born out of a discussion with Dr. Fernando Leite regarding a path to the future. And as we were talking about this notion of creating a path forward, we realized in our conversation that outlining the path from today's view was a bit limiting. And so we decided to free ourselves of the constraints that are created by today's problems and really use our imaginations to create future innovations, inventions, and effectively a more productive industry. One of our inspirations as we sat and brainstormed ideas was using cartoons from the 1960s that showed inventions that were in use today. And then we thought about NASA's space program and all of the inventions and creations that came out of that program that are in use today, but were created for a completely different purpose. So that's been an inspiration that we've kept throughout this whole process, and this notion of being innovative and not trying to solve problems really was a big driver. So Dr. Leite went through a large research project, and the conclusion is quite fascinating. And it outlines 12 future technology enablers that'll help guide you in a systematic way to help create new visions for the industry. So you'll hear about these enablers today when the three teams present their material that Rob outlined. And the enablers are used in challenges that we give to small teams that produce new ways to overcome constraints in the industry. So the titles that Rob gave you a second ago, a construction site with no cranes, that really is the constraining challenge. It's not solving how to make cranes more efficient on a job site, but it's really you don't have access to cranes, so now how are you going to build? You'll hear about these three challenges. You'll hear about the ideas that they studied to overcome them. And remember, the purpose in all of this is to create solutions with your imagination and use those visions to pull us into a future condition. At the end of each of the presentations, you'll have an opportunity to ask questions if you'd like, and the team members are here to answer how they looked at a particular challenge or process, as well as Dr. Leachy, if you want some expertise and level of information on the research that she led. So with that, I think we can launch into the first video and let's look into the future.
Okay, Kathy, if you would start the first video. When we get to the end of that, just hit pause and we'll switch over to the questions.
I can't hear the audio.
Very excited to be here. Also, I'm super excited to be here, and we'll talk today about no cranes in 2050. We were giving a challenge as a team to imagine a project site where cranes don't exist. It's a fantastic challenge. We're tasked to evaluate either non-cranes technology solutions or modifications with a few enablers that we'll walk through today with you. Our team has 2 employees from Zachary, Todd Sutton, and Ajay. You heard them earlier on the call. Please say hello.
Hey, good morning. Good morning.
All right. And then we have Abdullah Al-Suhaibani from UT Austin.
Yeah, good morning, everyone.
Good morning, and from Bechtel, Jennifer Monreal, and myself, Misha Nikulin. Very excited to be here with you. As a team, we came up with a vision for our challenge task to accelerate solutions that will potentially eliminate tower cranes on site. And you can read this vision vertically in blue. You can also see the full vision, the full version of that vision, which says accelerate the creation of the most efficient lifting and placing solutions for capital projects by leveraging emerging technologies that will positively impact productivity and safety and potentially eliminate tower cranes on site. So with that, I would like to ask Todd to talk next about some of our brainstorming session results and details.
Thank you, Misha. So during our brainstorming, brainstorming for the path to the future for no tower cranes 2050, we came up with different categories like flying things, robotics, and then also the new materials and also the additive material manufacturing as well. Emerging technologies and crazy ideas for year 2050 plus. Let's take a look now how we're working at to eliminate tire cranes with these ideas. Idea 1, heavy duty lift drone for placing materials instead of cranes. Here's an example of Griff Aviation's Griff 135. And idea 2, strong magnetic field for also placing materials in a different way. Here again is a 300-pound toolbox being lifted with the magnetic from Griff Aviation. Idea 4, crawling robot that can vertically and horizontally crawl on the structure to place materials. And then idea 5, lighted materials. This is shown with a gantry crane system that can also have vertical and horizontal movement across the structure. which looking at that for placing materials. And so looking at some other materials like biomaterials or plant-based materials. Here, bio-based is growing concrete bricks from bioorganisms. We have deal number 6, no gravity bubble tents. This is a crazy idea for year 2050 beyond. And we're looking at being able to have modules that are prefabricated, sent to the job site, installed, and also the prefabricated sub-assemblies. This is an emerging technology, the sky picker. This is a very small crane that can be used as needed on the project. Deal number 7, the additive manufacturing. This is looking at with a 3D printed foam platform. Here's an example from the Hassel plus EOC NASA Mars Habitat submission. And then I did number 8, flying platforms. This is used for placing materials and with the operator on the platform with material. Here also another example from Hassel, EOC, NASA Mars Habitat submission. So with that, we looked at all our brainstorming ideas and look at the different categories that we had put in place. Now I will turn it over to Jennifer.
Yeah, so once we started with our brainstorming, a lot of kind of taking a step back from the video, we took a look at everything and we divided it, as Todd was saying, into various subgroupings. So this slide kind of highlights some of the items that we had identified. So flying things, looking at drones, flying platforms, magnets, sorts. Next section is robotics. So either a crawling robot or an elevator platform, sliding robot, new materials, similar to what Todd was saying, bioengineering, lighter building materials in general, additive manufacturing. So 3D printed structures, temporary and permanent structures. And then emerging mechanisms. A lot of these are kind of in process today. They just may not be where they need to be. So exoskeletons, jetpacks, style lifting devices, a jacking crane from the top, jacking floors themselves, and then the crazy ideas. Todd mentioned a few of these in the video. So no gravity bubble tent, digging underground instead of building vertical, and then using artificial intelligence to utilize the tower cranes better. Yes.
So based on our brainstorming sessions and identifying our enablers, we identified 3 different milestones or to get to our vision of no cranes on a construction site. So enabler number 3, which is the equipment and facility modularization. If we look at a 5-year horizon, we would ideally like to explore more modularization, augment with other pre-existing technologies like, augment with drones or whatever's available right now. If you look at a 10-year horizon, we can look at bringing a manufacturing approach into the construction industry, explore concepts that that are employed in the manufacturing industry to leverage construction industry and to overall minimize crane costs. We can also look at concepts like biomimicry, look at nature, how problems are solved in nature. We can also explore ancient construction techniques to solve problems right now related to the cranes. If you look at a 30-year horizon, we basically have to look at limitations that exist with technologies that are available right now, like drones and magnetism, and try to minimize that to get the advantage of minimizing our crane tasks. And enabler number 4 was component standardization. On a 5-year horizon, we can look at prototyping and employ pilot programs to basically spread the available knowledge and basically create an outreach within the industry and educate people about the existing technology. If you look at a 10-year horizon, we're looking at expanding that inter and intra-industry collaboration and pairing up with other industries, like the military aviation, which will also give rise to knowledge transfer and sharing to solve our problems. And on a 30-year horizon, we can look at basically solving the problems of our regulatory authorities, changing specs with regards to employing all of the emerging technologies, promising technologies. So implementation is faster. So I'll pass it on to
Go ahead.
Thank you, Ajay. On the integrated, so enabler number 5, integrated information. In 5 years, we're looking at continuing a lot of the activity that's happening right now with the standardization of the different information data, but also with different organizations. One thing we're noticing now that's going to help us as we move on into the future is a lot of these initiatives for data integration, information integration is really interoperability is really being consolidated with different organizations like CII, PERT, and Mimosa coming together to solve these issues between the having the standardized data and information. So this will assist in the better crane design and also with the structural engineering. In 10 years, we're looking at how we continue those partnerships and modifying the existing techniques and practices, as well as developing new techniques and software architecture to fully integrate with the structural steel design. And then in 30 years, we're looking at how we can ensure the integration of information from the different data using AI, machine learning to easily seamless kind of allow for the data to be used regardless of what system you're using and having it being based on open standards. So going into enabler number 6, the human equipment computer interaction, in 5 years, continuing the work we're working on with leveraging existing robotic and AI knowledge techniques and designed to improve overall site safety and productivity. Going into 10 years, being able to allow for disabled employees to be able to work on the workforce by leveraging voice and natural language processing and bot technologies. And then in 30 years, kind of overcoming the current culture in which the autonomous equipment and robotics, people don't trust them, they're not safe or reliable, and making it more of a, be commonly accepted and also safe in 30 years. Abdul?
Yeah, for enabler 7, regarding for forecasting and simulation, regarding the 5-year milestone, we should utilize historical data to better design the efficiency and utilization of the cranes in the future. Regarding the 10-year milestone, we should go toward standardization and control project environment that will significantly increase our ability to forecast and simulate crane activities. Regarding the 30-year milestone, construction industry leaders should collaborate in building construction innovation centers and laboratories where new emerging technologies and their application and construction industry can be tested. That will also allow us to reduce the reluctance, the decision makers' reluctance about adopting new technology.
For Enabler 8, which is the micro planning and detailed engineering, in a 5-year horizon, we're looking at probably applying 4D and advanced work packaging. As we all know, CII is doing a lot of studies exploring advanced work packaging. So, and we can also look at leveraging augmented reality based approaches and also employing artificial intelligence to better plan and schedule our crane lifts or augment it with some other technology. In a 10-year time frame, we can probably explore a generative design approach. The automotive industry is already engaging it, approaching it. You can look at throwing your constraint and scope of work into a generative design software and see what best solutions that you can come up with to minimize or better approach a crane operation. On a 30-year horizon, we can look at expanding the generative design approach, try to automate it. Also expand the use of artificial intelligence-based planning and scheduling. Exploring lighter and stronger materials will obviously make or even minimize or even eliminate the use of cranes for certain operations.
So Jack, for the enabler number 9, sensors and state awareness, as we execute our jobs, we have equipment and material and people. So there are foundational sensors that need to be implemented today, whether it's telematics of equipment or material management and tracking of location, or people-related sensors that are maybe safety-related or location. These are all foundational, pretty basic technologies. They have to be implemented in the next over the course of the next 5 years. In a 10-year horizon, we want to make sure that we kind of combine and merge whatever we do during the engineering, procurement, construction, during EPC phases with operations. So all of the sensors that we install during construction have the potential to be leveraged during operations, which will bring us to the concept of a digital twin, where not only we can see things in real time like control systems provide today, but also predict failures or reduce downtime and do all kinds of forensics and explain behaviors or run simulations. And with the 30-year horizon, we'll need to widely adopt this digital twin concept with the unified standards and standards for sensor communication, standards for sensors themselves to kind of enable full integration, which will also require changing of our engineering approach and processes to really fully embrace design for sensors. So in the future, it's not going to be necessarily people entering information, but many of those data streams will be augmented by sensors to enter information into our workflows. Jennifer?
That flows into enabler number 10, which deals with automation across all aspects of engineering and construction. So this is something that a lot of the other infrastructures, or I guess manufacturing and whatnot, is leveraging and using currently. So within the next 5 years, construction really needs to take a look at automation and see how it feeds into foundations and locations, as well as what needs to be done with government industry regulations to align with automation. Within 10 years, we're looking at probably tying robotics into visual intelligence, artificial intelligence, learning from, like I said, the manufacturing retail industry who are currently using automation and robotics now, taking their lessons learned and applying it into construction and streamlining it. And then within the next 30 years, it's really going to be tying the automation, autonomous delivery construction portion into the design itself. That way they can go hand in hand and you end up with the design autonomy at the end of the day. Next piece is enabler number 11, which is your workforce health engagement. This is probably one of the most important bits of information now, since people is how construction moves and grows. So within 5 years, we'll be looking at establishing education programs to prepare the workforce for the direction, technology direction in which we'd like construction to move. A lot of that, and some companies are already using it, is utilizing AR and VR experiences. Within 10 years, we're looking at collaborating with the regulated industries to adopt the ES&H regulations, enable the emerging technologies, make sure that both ES&H and personnel and then the tools and equipment and structures themselves are all tied into one. Within 30 years, we're looking at developing new workforce assessments and certification programs similar to what we have now. These certifications would allow personnel to move across industries, move across areas, regions, states, countries, and understand and be certified to operate or be around either the tower crane alternatives or smart construction, or however you'd like to look at it.
Thank you, Jennifer. So this was a summary of all of the enablers. As you can imagine, we have detailed slides for each of the enabler with more information, and they will be available for the presentation. And we'll now conclude our presentation with suggesting a new challenge for the next set of teams. Jennifer?
Yeah, so as we are going through the enablers, brainstorming, discussing amongst the team, one of the items that kind of continuously came up is how do we safely and productively integrate robotics and emerging technologies into an industry while also ensuring that required regulations are aligned to advanced design and construction. So Todd had actually mentioned, so one of the items that was the sky picker in the video has actually been developed, and the company tried to implement it in the field, but it was shot down because it didn't really fit with the current regulations, current standards that we've got now. So nobody knew how to address it. Nobody knew how to ensure that it's safe. Nobody knew where it fit in today's construction industry. And that is going to be one of the biggest challenges that we're talking about for seeing. It's not developing the technology, it's seeing how it fits into an industry which is already considered unsafe by all means. So it's one of the challenges that we saw as a good opportunity to get another brainstorming session.
All right, that would be it from our team.
Okay, so thank you to that team that recorded that brainstorming session on what a construction site might look like without cranes or beyond cranes. Todd Sutton, you were part of that brainstorming group, and I've got a first question for you. On the regulation of the free flyers around a construction site, what if the construction drones were tethered? And what if they were limited in the altitude that they could fly to? Do you think that would allow them to operate without the FAA drone or free flyer constraints?
It'll still be under FFA, but there are regulations in place for allowing that to happen now. But as far as having the multiple drones, in the flying platform, some of the other technologies that we talked about, That is not regulated yet. So, but as far as Part 107 FAA regulations, you can operate. Again, the tethered would allow for longer operations because you're hooked up to a power source as
Right.
well. So you're not limited by the battery limits and stuff. But but right now you can be from 400 feet from a structure. You just can't fly over. So there are some restrictions about flying over people. April the 21st. There's new regulations that went in effect, but it requires the drone manufacturers to reclassify and get approval for their drone to be classified as either Category 1, Category 2, or 3, and 4. Category 1 and 2 and 3 can be used over people with restrictions on notifying everybody that's in the closed restricted work site that they're going to be operating over them.
Yeah, and that's kind of like, rules associated with lifting over people,
Yeah.
which generally, frowned upon.
Yeah. That is exactly true. And there are just the follow up on that one. In regards to the sky picker crane that was actually developed and put in use on a project in New York City, what happened on there, it got approved by the one administration, and then it was retracted from another mayoral administration, basically due to the trades and from the unions requiring basically that that crane be classified as a tower crane, which it's not. It's a lighter weight crane that can be moved from floor to floor, so it's not a tower crane. The idea is you would lift it up as you complete each section of the building, and they're therefore requiring the same regulations that a tower crane would be made. And then what happened when they came back and the union said no, it needs to be classified as a full-blown tower crane, which basically shut it down. And then it also had to be operated by a union crane operator. So,
right.
I see that's. But as these new technologies come about, I can see this type of regulations still being enforced for the newer types of technologies that we talked about in our presentation.
Okay, if others have questions for Todd, please put them into the chat. I see a comment from Andra K about using blimps as opposed to driven drones. Any thoughts on blimps, Todd?
Yeah, that's one of the things that we had discussed in our presentations as well. But yes, you can, but you would still a blimp type solution would give you, you can lift a lot more weight, and also the power required to operate it is a lot less too. So because you're just using it for directional, basically, yeah, so I think that would be another option.
Okay, I think in one of these construction concepts, the idea has been to do all the construction on the ground floor and jack, floor by floor up, so that all of the primary work is done at grade. So you build a floor, you jack it up one level, build the next floor under it. Any thoughts on how that would change material flow or the need for cranes for lifting at a construction site?
It can reduce like what we were demonstrating. It can reduce the need for a tower crane to be on site the full time. A lot of times a tower crane will sit there for several months when it's not, just because it's needed for a pick later on at the end of the job. So I think some of these newer top solutions would minimize the need for that on the job site.
Okay. Any other questions coming in on the chat? All right. And I'll just, one other comment on safety of drones. My day job's at NASA, and we've been doing a lot of drone operations, and we built basically a large net structure over our work area.
Yep.
And the net, of course, didn't block out the drone's ability to see the sky for GPS and other communication.
Right.
But because of the net, the rules for operating the drone went away.
Right.
Away. We called it the pterodactyl cage, like a giant net. So putting a net over a construction site like that could could change things too.
That's true.
Well, all right. Thank you, Todd. Okay, let's move on to the next topic, which is imagining what a work site, a construction work site might look like without people. So, Kathy, if you could go back to the video and pick it up from where we left off.
This is team 2. Our objective was no people on construction site is in operation. On the team was me with the floor as part of the construction visualization. Our UT student who's unable to join us today is Nicole Barrion. And then we have Bill. I don't know if you want to introduce yourself.
Yeah, I'm with ExxonMobil. Most of my career has been in downstream oil and gas project management.
Great. So let's move on here. So got a few kind of examples that I wanted to show. If there's a few key technologies that we kind of looked at as the in our 5-year milestones. Is first the Spot robot by Boston Dynamics is able to do a lot of activities, move equipment around, and in a fairly automated fashion. And another one was Robotics, and this is a in collaboration with a haptic feedback glove, where you could put the glove on and then control the robotic arms and feel kind of force feedback to manipulate objects. And these are kind of where we started. So our first vision is kind of beyond the singularity, which means when AI and machines kind of meet and then surpass the capabilities of humans. So this is everything from selection, design, fabrication, construction, operation is conceived and executed by these machines and AI. So the benefits of this is that it is by and large probably the most cost-effective solution. If an AI is able to manage an entirety of a construction project from start to finish, and it reduces human interaction by having them doing the most complex operations that a machine may or may not be able to perform. So Bill, if you want to explain.
You want me to take the next one? Yeah. I see on slide 4.
Yeah.
So we also have an alternate vision, and it's not a world where everything is done by machines, but a world where humans interact and control machines. And there are two forces which could propel this vision. Complex and changing conditions where programming and designing machines for all the variations is really inefficient. And the second reason for it is societal change. Governments may impose minimum employment requirements to avoid social breakdown when no one has any jobs and possible income. So in this world, people would operate machines remotely. The video that's here, I guess we won't be able to show.
When it links up with the rest of its pals. Things get a little more interesting. The microbots are controlled with this neurotransmitter. I think what I want them to do. They do it. Applications of this tech are limitless. Construction. What used to take teams of people working by hand for months or years can now be accomplished by one person.
5. So we see the path to no workers as taking two trajectories. The one for no workers is foreseen, but there's going to be a societal change before it's realized. And the second vision is where there are workers, but they're remote from the work phase. And I'm not so sure what the societal change will mean. So we have these two visions. So we'll take a look at the enablers for no workers in construction and operations and go through them as the previous group had done. So the first one is enabler for fast and reliable payments. You got that slide, Corey?
Yes.
Okay, so we don't see this as a major enabler of no workers on the job site. You may see automatic payment based on RFIDs in the near term, or maybe the application of blockchain in the medium term, and possibly in the future, some automatic distribution of societal benefits from project revenues. So we don't quite see these as driving to no workers, but they may be aspects that happen as we go forward in a no worker regime. So Corey, you want to take the next one?
Yep. So our next enabler that we considered, and we considered this as a major enabler, is the modularity of multifunction equipment and facilities. So in kind of our 5-year milestone, we really considered the modularization of the equipment and the components, which would reduce the number of workers on site as they kind of things would be assembled in a bit more efficient way rather than having to piecemeal assemble everything. We can have plug-and-play module designs, which reduce the complexity and reduces the need for some specialty workers on the construction site. Then we can move into things like remote sensing equipment using robotics and drones and IoT functionalities that are currently available to us today. And then modularizing components for robotic assembly and moving construction to something similar to an assembly line. And then in our 10-year milestones, we considered new materials or combining waste products to create new building materials. So in this case, plastic concrete was just kind of an idea that we had thought of. And again, this is approaching the assembly line once again. So if we can apply that thinking in a more real sense to construction, then maybe there's almost nothing that in the future wouldn't be built on an assembly type line for capital projects. There's a lot of advancements with communication and telecommunication. So with the advent of 5G coming, we might see more data bandwidth. So with the advent of 5G coming, we might see more data bandwidth.
So Robert, I'm not hearing any audio.
Sorry about that. I don't know what's the matter with the video. Hold on one second.
And you can standardize the design process for the entire facility. The philosophy is design one, build many. And into the 30-year milestone, again, there's this material standardizing the materials as kind of the building blocks for making all of these components. You can build a customized component or facility rather than a standard design, which is inefficient, but you could use 3D printing for that purpose. And then software, which would be minimal design, and then feed that into the manufacturing. So Bill, we have moved on to the next slide.
Okay, slide 10, integrated information. So we see integrated information as a major enabler of workers, of no workers. In the short term, sensors can reduce the maintenance personnel by predicting failure and allowing intervention before failures. Augmented reality can contribute to fewer workers by working more quickly and accurately. In the medium term, sensors will allow better designs against failure, leading to fewer maintenance people. In other words, if you know where the failures are occurring, you'll just beef up your design there, and you won't have as many failures, so you don't need as much maintenance. In the future, sensors may become integrated with materials, helping to maintain them. Think about concrete or steel that would change color based on stress, for instance, and then you could help maintain operations, or maybe you could feed back into the operations. If there was high computing power, maybe the weather environmental conditions can be predicted, so you can have more productive work along the way. So we think that's a major enabler. Next slide on human equipment computer interaction.
Yep.
So I was going to say, you saw in the opening video with Ted Bezos that the telerobotics is on the next horizon. That was you put a glove on and you can manipulate a robot, but you can also get sensors feeding back information to your hand to say how heavily you're squeezing it or how heavy it is. If computer-aided design will result in fewer designers. I'm already seeing that when I go to some of the APC contractors. The robots that, well, we didn't able to show some of those videos, but the robots can now handle non-symmetrical materials, boxes that are different sizes and shapes, picking up things that are like bolts versus nuts, things like that. So those are already progressing. 3D concrete printing is on the near horizon. I've seen some applications in the commercial world, commercial business, to show that you can do 3D printing of concrete. No reason why we can't do that on the sites. It'll start to eliminate some of our form workers and rebar workers. In the future, you could see swarming robots. That was the spot video that you didn't see, but you could have multiple of these robots walking the site, delivering materials that are able to go upstairs, around objects, and so forth. And the nanobot type video, which you didn't see, where there's swarming robots. In Vision 2, the humans would be controlling the machines remotely, which could be a safer situation. The video that you can't see here is what was the video there, Corey? It was the Iron Man one. Yeah. The robot is flying around and he gets into an accident with the truck and it destroys the robot. But the guy's okay because he was remotely controlling it. So you could get into a safer environment with remote control of machines. Okay, the slide 13. Forecasting and simulation fidelity. We didn't see this as the major enabler of no workers. The digital twin may reduce the workers on the site for operations, but we didn't see it as much of a contributor for construction workers. Corey, I think you got the next one on microplanning.
I do. This enabler is microplanning, and we consider this as not a major enabler of the no workers visions. So in our 5-year milestone, we could see greater computing power, which would allow for a greater number of components to be simulated for the assembly, more detailed instructions for workers, increased productivity, and leading to fewer workers. You can plan your model based on work processes rather than scheduling. This can allows the mathematical optimization of schedule, resources, cash spending. Then Bill may want to elaborate this, but the project production management applies operations science to heavy industry. Bill, I don't know if you want to speak to that a little bit.
Yeah, it's just it's another application of operation science, which is coming out of California, Stanford, similar for Alice Solutions, where you lay out the work process, put your resources on each step of the work process, and then you can start to optimize for schedule, inventory control, cash spend, and it's done mathematically versus what we do now, which is kind of a hand situation with P6 and some of the other software tools.
Yeah. And then that same kind of thought process is being applied to the automotive industry. And the idea is that heavy industry would be able to do the same. If in our 30-year milestone, we may be able to have AI become more predictive to allow for more uncertainty in their predictions, which would allow them to be more productive or provide more productive provide more productive information for use of resources, leading to those fewer workers. And our next slide is on state awareness. So we also consider this one not a major enablers of no workers. But this one is just kind of knowledge of the status of the engineering, of the material, which phase of construction it's going through the use of sensors, and different work processes, which lessens the variability of the work processes. So and provides more productive use of those resources. Then next is having that information be available to AI for predictive maintenance. So getting to a state where instead of scheduling maintenance, we can get to predictive maintenance to use those resources in a more productive manner. There's an example where you have a lot of sensors in an aircraft engine, as an example. So you know if something is going wrong because the sensors provide that data. In our 30-year milestone, then we may be able to have sensors provide accurate data enough to where we don't have to do predictive maintenance, but we can have that sensor provide the information kind of as a just-in-time maintenance thought process. And then the last one, well, not last one, but so the next one is the workforce health and intellectual engagement. So we kind of divided this one up into two sections. For our vision one of kind of the AI singularity, we didn't think that this was necessarily a major enabler of no workers. But for our vision two, we did think it was a major enabler of workers, which was having humans augment more dumb machines. So if there are no humans involved with the process, then there is no workforce. So that's kind of what we went through with our vision one here. So with our vision two, there's training for a lot of people on how to interact with machine and AI to optimize tools and become more familiar with AR and VR and robotics, because that is going to be the eventual direction of this industry. So having people more familiar with it allows them to integrate with the industry easier. and it allows people to take the time to teach creativity rather than repetitive learning to enable that innovation in the future. So as an example, thinking about how to change an existing application to serve another function rather than just operating that same application with no thought to how to make it better. And then continuing on to our tenure, kind of going back to the assembly line thought process, you can standardize the design of parts, modules to fit together quickly. It frees the workforce to from those more mundane tasks to allow them to engage more intellectually. And then in our 30-year milestone, we've got a challenge to use AI to produce new tools and processes to solve the problems, and then move away from physical labor to more problem solving. And Bill, we've hit the next slide.
Okay. So as you can imagine, automation in design, construction, and operations would be a major enabler for no workers. Rule-based design for engineering is here now, and wider application will happen quickly, reducing the number of designers. We can add more variables into consideration for more efficiency in our construction processes. Take care of construction congestion, optimize the use of cranes, those types of activities. In the future, the AI can do overall optimization between design, procurement, and construction to optimize the entire process and building the plant. In the future, we can also get design integrated with robotics, so the design can actually control the work done on the construction site. I think the video that's there was a video where a designer was telling the machine, oh, make this longer, change the color of that, and the machine would actually do the design in conjunction with the, I'll say, the creativity of the human mind. The last enabler that we wanted to talk about was the environmental sustainability. So we didn't find that environmental sustainability was a major enabler of no workers. What we did find is it will have a major impact on the workers. For instance, the types of projects may change. Infrastructure projects for water, environmental control, carbon capture, transportation, waste recycling may dominate in the world. And projects with a heavy environmental footprint would likely diminish, or maybe you would create those projects on a much smaller basis closer to the source with 3D printing and so forth. So it's not a major enabler, but it will impact on the skills that the workers have and how the plants are built with less, movement of soils or wetlands, how big they are on the footprint, maybe co-locating energy generation with the plants, and handling waste at the same time you're, or recycling products at the same time you're making new products. So the last slide is the new challenge, right? And as we showed in the opening graphical slide, we think that as the world progresses towards fewer and no workers, there's going to be an enormous societal disruption and impact. Questions are, how do you share the benefits of projects? When nobody earns a salary, none of the benefits of the project get shared. And then the question is, well, if nobody has any money, why do you need the project? So, and how do you keep society from breaking down between the haves and the have-nots? You're starting to see some of that now with the 99% protests. Maybe you could even say in some of the political dysfunction that we have now in our country. And then you have this question of how do you provide stimulation of personal self-worth and satisfaction and challenge. A lot of people get that from their work, which then kind of leads to another question, which is how do we transform from a consumer world to another value system in order for the world to be sustainable? Would it be a more intellectual world of personal well-being and spiritual value or serving others? Will we be using automation to blunt the environmental impacts? And how does this actually come about in our thinking and our desire to have it come about? So I think that from all of what we've seen today, there's certainly technology that's moving us now and will be moving us in the future to no workers on the site.
For Challenge Team 7.
Okay, thank you for pausing it there, Kathy. And Bill, you're online. Dr. Leach is also here. I want to ask you a question about remote workers. I know that major equipment makers like Caterpillar and others have invested a lot in how to make their machines operable remotely. For construction that's very distant from population centers like road construction, what are your thoughts on the operators of those machines being, say, in Peoria or post-pandemic being anywhere around the world, operating those machines at remote construction sites?
Well, I see some of it now, but not quite as remote as you describe it. Right now, there are like headgear that you can put on with cameras, and you can talk and you can interact with a worker on the job site. If you had good connections, like the 5G, you might be able to. Certainly have to have a lot of safeguards in there. If the connection breaks, the machine stops, right? Or something like that. I don't think it's that far away. There's probably a couple of things you got to take care of on the connectivity and the safety.
Yeah, so
one thing that I'll add, sorry, go ahead, Bill.
No, that's all I have.
I was just going to say for roadbed construction on roadways, the vibrational compaction machines are not pleasant to operate. Riding on those pieces of machinery, it's not pleasant. So you don't want to be on them anyway. And if you're going to be remote, tens of feet or hundreds of feet, hundreds of miles might also work pretty well. And it's a rather repetitive operation, driving back and forth over the roadbed. And of course, roadbed construction, roadbed compaction is almost the most important thing really in the life of a roadbed. So being able to...
We do see that on our construction sites now with smaller compaction machines that are remotely operated, like on a tether with a joystick. Fernanda, you were going to say something.
Yes, I was just going to add that I think that as we get more and more sensing embedded in our job sites, more and more modeling, we're able to extract more contextual information to be able to operate more and more remotely. So I think that's the key is really providing whoever is the remote operator the contextual information that's needed to accurately, effectively operate that piece of equipment.
Yes, and some of the equipment even tells you, how it's performed. Like again, back to roadbed compaction, the latest machinery measures, that every time it compacts, what progress it made. So it's kind of measuring the bulk modulus of the soil and building a map of where
Yeah.
it was no longer being compacted or where it's still making progress. That kind of map gives you that sensor-driven map gives you that context of where you need to continue to work, and then where you need to add additional material using a different piece of machinery. Of course, at NASA, we would like to do that very remotely, because being able to build a landing pad from Earth would be, really a useful thing to do, and being able to operate that equipment from mission control, is really our vision. Thoughts? Any other questions coming in from the chat? Okay.
And I'll just provide a little bit of background on, you've been hearing in all of the presentation, technology enablers. And as the challenge teams have been presenting their work, they contextualize it under this framework of technology enablers. The technology enablers, there are a dozen of them, and they basically were developed as part of the research project before we got to the challenge teams. And they're basically an abstraction of ways that we can make the work in the construction industry more efficient and more to increase productivity and to increase efficiency. So an example would be, for example, standardization or a graphical user interface, right? So there are different categories that we can actually remove that processing, the human cognition from that activity, so humans can actually focus on more complex, higher level tasks. So it's all about, those technology enablers basically are all about how do we make the work more productive and more efficient. And that's what the challenge, that's the language that you're hearing there in the presentations.
Yeah, I thought I'd add one more thing. This path to the future is a framework to think about how to get to the future. So if you just sit down and say, well, what's it going to be like in 30 years or 2050, it's hard to jump from today to the future. But this framework to think about these enabling technologies that Fernanda just described and look at it today, 5 years, 10 years, 30 years, is a way for you to visualize how you can get from today to long-term in the future. And that's really the value of this kind of methodology and why you see these kind of standard slides that come through the presentations. So take your problem and break it down this way, and you might see a way to the future.
Thank you, Bill. That's well said.
That's very good. And there was a little bit of discussion about concrete pouring, and it may be that those amazing concrete pump machines that we see on the construction site, they are essentially additive manufacturing machines. And as those become more and more remotely operable, we don't need as many people out at the end of the flow, which is dangerous and dirty work. It might be that the machines that we already have on the construction site just start morphing more and more into a robot, and that's more of
well, there's some other technologies that go with it. So right now we put rebar in and then pour the concrete over it. Some of the things that we're looking at are fiber reinforced concrete, where you don't use the rebar, you just put the fiber in the concrete, and now you don't have that step. So combine that with your robotics, and you're starting to make some real progress.
Yes. All right. Well, thank you to this panel. Let's now go to the third topic, which is how to be able to do all of this work, no matter what we're seeing in the weather. Obviously, weather has a huge impact on our construction costs and schedules. Kathy, let's go back to the video and play the next segment.
The only thing
Hi guys, part of Challenge Team 7, I'm Ariana North. I work as an advisory consultant for Deloitte, specifically for infrastructure and capital projects, as well as on some of the energy side of that as well in mining. I'll pass it off to Cody.
I'm Cody Austin. I'm a technical solutions executive at Autodesk. I've been in the industrial construction space for about 15 years. I've been working with Autodesk for the past 8 and have been a CII member, I think, for the past 4 or 5 years, and been engaged in other research topics and teams. Lisa?
Hi, my name is Lisa Okafor. I'm the IT product owner at ExxonMobil, specifically for our capital projects applications. I've been with ExxonMobil for 10 years. All of my experience has been in IT. For the past 10 or so months, I've been working with our capital projects division, specifically working with applications, dealing with estimating, project sizing, flow estimating, things like that.
Okay, hi, I'm Jose Miranda. I'm a grad student from the Civil Engineering Department in the program Construction Engineering and Project Management. Actually, it has been very fun doing this challenge about weather with no constraints. So now I pass out to Cody.
Yeah, so just a reminder of what our challenge is, job sites with no weather constraints. Our challenge was to imagine a construction job site where weather does not impact work continuation, independent of outside weather events or other acute stressors such as hurricanes, snowstorms, earthquakes, sandstorms, tsunamis, etc. We were to think about means, methods, or other technologies that would enable projects to build through extreme weather events or stopping weather events altogether. As a team, we identified a few tasks to evaluate the available means and methods and technologies to mitigate weather impacts, identify modifications of these methods or technologies to build through extreme weather events, and then brainstorm, innovative ways. We're 30 years out from today, where some of these means or technologies may be that could help stop or manipulate future weather events. And so we identified 5 enablers that we felt were focused on this challenge. We'll go through those here in a second. But the reason I joined this team was because I thought it was kind of a crazy challenge, stop weather events. I mean, how are we going to control the weather? You see here, a picture from The Simpsons where they put a dome over the city, and we're going to have to put a dome over our construction sites. Or 30 years from now, we're going to have some genetically modified mutants that can control the weather, like Storm and X-Men. I'll open it up to the team to maybe add some of their thoughts on this particular challenge.
Yeah, I would agree with you, Cody. There's a lot of cool ideas that we came up with at first. And one of them, and I don't know how many of you guys are Disney Channel fans or have been there before, but there's a movie called The Ultimate Christmas Present. And Santa happens to kind of drop this little robot as he's leaving a house. And this robot gets kind of picked up by one of the children living in the house, and it controls the weather. So it can make it snow, it can make it sunny, all that good stuff. So that was what I kind of immediately thought. And what a cool way to kind of control the weather that way. But those are my thoughts.
Thank you, Rihanna. Yes, sir, Jose, any thoughts to add?
No, just kind of echoing what you said, Cody. Definitely a crazy challenge, because when you think about it, it's kind of like there's no way a human can control the weather or control the sun or moon or anything like that. And so I think it required us to really think outside of the box, and even some of our crazy ideas were like, well, maybe we can find a way to make that work. So it was definitely something that was a lot of fun to be a part of, and really try to think out of the box and see what we could come up with.
Thanks. Let's see. So, weather impacts us all, and I think Lisa was going to cover, or Ariana, I can't remember who's going to cover.
Yeah. So I was going to go ahead and cover this, Cody. So basically, over the past several years, there have been many different things that have, or many different technologies that have improved weather forecasting overall. From the early days, having a weather balloon. Not sure if you guys remember what a weather balloon is, but it was a balloon that carries instruments that sends back atmospheric pressures, temperature, humidity back to us, so we could somehow estimate what the weather would be for a particular day or time. We would also have different aircrafts that would go in and even today still fly into hurricanes to really understand the impacts of some of these things and predict the weather for us as well too. Nowadays, we've gotten a lot more advanced with how we predict the weather with different computers and radars and radios that tell us what to expect, even sometimes a few weeks out. I feel like this year has been a very, very heavy hurricane year, as is 2020. And so we're able to predict some of these hurricanes that may come to the coast even 3 weeks out. And so even though, and as closer as we get to the time, we get a bit more accurate with the different radars and computer prediction systems that we do have as well too. Weather satellites are also a huge item that we use to predict what the weather will be. This is probably one of the more common things. And then the NOAA all has this weather radio, but something that we all have access to, and it's a FM weather radio station here in the United States that kind of broadcasts what the weather information is going to be. So essentially the voice of the National Weather Service. And then also a tool called Automated Surface Observing Systems. And what this is that they are little units or automated sensor suites that are put all over the US that are designed to serve as meteorological and aviation observation needs. So they kind of send signals back to help us what the weather is. And so there's about 900 of these ASO sites here in the US.
So based on our kind of understanding of how we brainstormed and some of the older technologies and history of meteorology, we came up with a team vision, mostly focused on 3 facets, but just kind of encompassing how do we better predict weather, how do we weatherproof construction sites or materials in order for construction to take place, say in a climate controlled environment, or how do we reduce those on-site construction durations based on rain or snow or that hurricane that hit that one time, and how do we reduce humans that are required on site, specifically if you're trying to put in a window system in a snowstorm, how do we reduce that risk? So basically the whole thing here is to reduce that weather related risk and improve productivity with investment, creation, adoption of weather prediction and weatherproofing technologies for capital projects.
All right, so I'll walk through a couple enablers here. So the first one is enabler 8, detailed engineering and planning. And we thought that this was really important if we want to really reduce that risk that Ariana mentioned. We need to reduce the amount of time that we're spent, constructing on site, out, exposed to the elements. And in order to do so, we need to reduce the amount of time it takes to install on site, but also reduce the amount of things that are installed on site and move a lot of the construction indoors to a climate controlled environment. So we talked a lot about design for manufacturing and assembly and DFMA, and how those processes really need to be driven into the detailed engineering and planning phase, so that these projects can be modularized and prefabricated. We really need to start with the end in mind and work backwards from there. We can't, you know, we can't detail engineering plan, you know, and then decide to, you know, prefabricate and modularize. We really need to think with the end in mind. And this also plays into moving away from custom components to more standardized components and off-the-shelf solutions. And moving into the 10-year, we talk about, you know, plug-and-play technologies and off-the-shelf technologies and really configurable platforms and configurable systems versus that bespoke, you know, custom every time. And then moving on into the 30-year time frame, we see a lot of these tasks becoming highly automated with the use of data and the explosion of data and the use of artificial intelligence and machine learning, which we'll talk more about in other enablers, and also moving towards more of a configurable platform or product focus. And kind of more online sales configurators, right? You go online, you can configure your Tesla and, you know, have it delivered to your house, for example. I think we as an industry perhaps need to move more towards, you know, that direction and have more configurable solutions versus these custom and bespoke solutions. Again, these are going to help drive that, you know, that more manufacturing-like mentality when it comes to construction, allowing us to move these activities indoors where the weather is controlled and we have, you know, more control, you know, over our environment. And the second enabler I'll cover is number 3, the equipment and facility modularization. And this really ties into that detailed engineering and planning. You see here some images of industries and applications where this approach is already taking place. And in the top left, you have Systicon, you know, installing in place a modular solution. On the bottom left, you have, you know, an example from Marriott. You know, hotels, for example, are prefabricating, you know, complete suites, you know, outfitted with furnishings indoors where they're installed on site in a matter of minutes. You know, what would have taken, you know, many hours, many weeks to take place. So from a 5-year perspective, we really need projects and contractors and owners to adopt the best practices that have been identified by CII into their project, you know, incentives and goals and processes. You know, really, you know, incentives drive behavior, and so we need to make sure that these best practices find their way into how we're executing our projects and into things like contracts, for example. But again, you know, design with the end in mind. You need to, you know, very early on determine this type of construction so that detailed engineering and planning can follow suit and design appropriately. Maybe in the 10-year mark, we see, you know, maybe more than 50% of the project is prefabricated or modularized. You know, we're seeing a transition away from the construction site and into these climate-controlled spaces. You know, perhaps we could have been a little bit more liberal with this and maybe gone to, you know, 80% of construction is prefabricated or modularized in 10 years. But here you see with 30%, we just kind of see that shift away from on-site construction and more towards a manufacturing type approach. And I'll hand it over to Lisa on this one.
All right, so the other item that we wanted to focus on was automation, because we thought that there was a lot of opportunity to get a lot of these processes automated when it came to construction sites. And so 5 years out, some of the things that we thought were possible was implementation of data-centric workflows, such as BMI, regulated by the industry data standards. And so what this would support would support automation throughout the whole project lifecycle, specifically around things for prefabrication, like Cody was talking about earlier, and modularization. So this would help not only make things faster and easier, but hopefully reduce any type of error that's involved, and get away from a lot of the human interaction that is involved in building some of these sites. It would also help us keep on schedule, and even if there is some kind of weather constraint as well too, maybe we're able to go a bit longer than usual if there is some kind of weather event coming along. A lot of this, to achieve this, we would be using a lot of generative design and learning to accomplish this. 10 years out, we would definitely leverage more generative design and machine learning using the digital data collected over the years. And so all of the data that we collect, we would be able to optimize engineering and design in support of prefabrication and modularization. And so basically just a more advanced version of what we have at the 5-year mark. We're able to get things more automated, get things done faster, and get things done more accurately based on the data that we've collected in years prior. And then 30 years out, we're hoping to limit all type of human involvement and have all of this be completely done by weather-resistant robots. So there's very, very little human interaction involved. The human interaction that would be involved would most likely be off-site from an office somewhere. And then when it comes to weather as well, since they are weather-resistant robots, if there is some kind of bad snowstorm or rainstorm or hurricane or something like that on the horizon, there wouldn't be a need to stop any type of construction at all, and there should be we should be able to continue with construction at the site since it is weather resistant. And so this would help us prevent any type of delays and any type of further cost that is needed if there is some kind of storm that rolls through and destroys the site. If we have some kind of dome or weather resistant robots, that should help us with that. So next slide.
And so if we continue with this idea about how we can integrate all this data collection and make it more automated, we can also change another point of view about how we prepare the job site, so we are aware about some hurricane that is coming or some big storm. So first we need some layer of data collection, and here's when this enabler, sensors and state of awareness came up, because with sensors that collect all the environmental parameters such as the air temperature, carbon dioxide, light, that can help us to predict accurately what is going to happen. And here we put in 5 years that the piece of the Internet of Things devices will help us to automate every solution that is came up about how we can prepare the job site. And here we add a picture about this TV show Westworld that is at the lower right corner. So a huge machine without the interaction of humans that came up with solutions more fast. So, and continue with this idea with a deep reinforcement learning, we can personalize all this weather information. So, such as they are can be anywhere part of the earth, also in the sense like we also think about sharing data between different stakeholders. We improve all that we call that the cloud computing layer, that is computing the different sources of information in real time. In a 30-year goal, think about that more than 90% of all the things manufactured are connected to the internet. So we are sharing all the different information that we really think that it's already there, but we are not using. And sharing all this kind of information will be capable of hyper accurate weather modeling and forecasting. So In the next slide, you'll see that all this information will help us to forecast what is going to happen not only in 10 years. Can you put the next slide up, please? Well, also because right now we see the forecast only 10 years from now, but we think that maybe in 5 or 10 years, we have a really accurate forecast in 30 days or maybe more. So all the job site will be prepared for example, the Hurricane Laura. If we know that this will happen with a year or a month previously, we will have less impacts of weather delays. Also we think about the climate change that is happening right now and how we can accurately predict which weather will be in the next days in the coast or in central Texas, for example. And similarly, we will improve the modeling of these different parts so it can help to make accurate bits so we are prepared and we can put an accurate times of the delays as buffer for each job site, and we will have more accurate cost, and also we can improve the profit of each one. I don't know, Cody, if you want to add some thoughts about forecasting.
Sure. Yeah, just one thought from mine is, we have to make, in the case of Hurricane Laura, there's many projects in Houston that had to shut down or had to, make preparations in the event that, Hurricane Laura did not take a northeasterly, turn, right? So if we have better data, we can have more accurate forecasts and really better understand risk and prepare for risk more appropriately. This takes many weeks, to prepare for a hurricane and to start back up for a hurricane. And as I mentioned, we didn't get a single drop of rain in Houston from Hurricane Laura. So just imagine all the waste in terms of cost and time that took place because of the chance, or the risk perceived that something that the hurricane, may not change course. Ariana, did you have some thoughts as well?
Yeah, definitely. So the other part about forecasting and simulation is investment. It's on the financial side. So at this point, at our 5-year milestone, even I would say now, the investment into forecasting and simulation is actually not as much as we think it is. It's more about the startup culture kind of investment. So folks are going to take chances. They're going to invest in small companies that have developed certain means of technology to make data collection better, to base their models off of historical data or maybe climate science and how that's changing. So at this point, folks would be reducing that uncertainty with respect to construction execution or project development at that point. On the investment side for the 10-year milestone, those investments have grown substantially and will continue to grow as climate change and as weather events get more extreme, or we need to be predicting them in advance. And in this case, we're thinking about 1 month beforehand, we get accurate weather predictions. So no more of looking on here Apple weather and seeing, oh, there's only predictions for the last week. This would be a month in advance instead, and that would be with over 90% accuracy. So as a construction project management side, project management oversight, you can predict what activities can be done or what materials can be installed with 1 month ahead of time. So that schedule will get better, and there's no uncertainty with that for the owner. And our 30-year milestone on the investment side, weather forecasting modeling will be incredibly accurate. And in this case, it'll be hyper local because so much money has gone into it that weather will be predicted at such a small scale, think of pixels. So pixel resolution is getting better and better. Think of that in the terms of predicting weather, but maybe for a single building in a city, which is, is it going to rain on that building? What % chance is that? And in this case, construction sites will be able to manage risk well in advance. So a couple months, maybe 6 months in advance, if there's any weather events. And if we move to the next slide, we can wrap up pretty quickly, but we spend a lot of time trying to figure out what the new challenge we were thinking of suggesting was. And we threw out, if I remember correctly, permafrost. How do you build on permafrost or sinking ground? Maybe how do you construct buildings or technology at a deep sea level? But we realized that, and the team can chime in a little bit here, that using 100% sustainable materials is a challenge in itself today. And I've only been on a few projects lead-wise where we use 30%, and that's tough to get. Because if you get 100% stable materials, then you're golden, I would say. Cody, Jose, Lisa, any thoughts on this one?
Yeah, there's lots of focus around sustainability. Many of the members of the CII organization have cultures and initiatives now around sustainability and improving the world. And so just kind of taking that, a bit further and making it really challenging is, how can we be more sustainable in our material selections, right? Our construction materials. And so we've seen evidence that it is possible in some industries, or they're already making dramatic shifts in that direction and incentivizing their projects to do so. I think it could be, a really big challenge in other industries. And so that's why I'm excited if this one is chosen to see what the team comes up with.
Also, I'm super excited to be here, and we'll talk today about no crane.
Let's, Kathy, stop that. All right, so we got to the end of the no weather constraints section. We've got Ariana, who was part of that panel. Got a first question for you. I know the idea of putting a dome over a construction site sounds kind of like a crazy idea, but it seems like the costs for those structures are coming down, and the ability to even have just one part of the construction site covered and be able to move that around might not be such a crazy idea. Have there been any attempts to do that at construction sites that you're aware of?
That's a great question. It's a good futurist question too. I think in some cases there have been some attempts. I can't point out specific examples, only because my experience is a bit limited. But this is particularly for below grade and kind of ground level foundational work. That's key to any good strength of a building. As you get farther up, you kind of switch over to more of the warehouse feel. So you prefab a lot of that work in warehouses or large buildings such as that, and that dome kind of goes away. But in order to preserve that ground area, especially to prevent flooding and water damage and foundational aspects, is key and important. And in some cases, I think the East Coast has done that. California, I know that there are certain aspects of that has been done. And yes, the Chernobyl site, the nuclear way, has also been domed. But remember, that took almost 30 to 40 years to construct securely and heavily to prevent that radiation escape. So it's if we can reduce the cost of that, then we might be able to reduce any further risk of sites exploding as well.
Yeah, so the Department of Energy has used domes out west in the Idaho Falls area where they were going to do excavation of a site, which produces a lot of dust. And if the dust is contaminated, that's an environmental problem. So it's interesting, in that case, the dome wasn't to protect the work under the dome from the outside. It was to protect the outside from the work under the dome. So that kind of a containment barrier actually is a twofer. It could both isolate the work from the weather and reduce dust. Dust is a major problem in urban areas also, where dust at construction sites covers all the neighbors, and they complain. And it's also a kind of a micro pollution problem, in a local area, and can have big health impacts on the neighbors. Other questions for Ariana on the no weather constraint to the construction site concept? How about manufacturing at the construction site? If you deliver kind of a portable factory where you can be doing manufacturing, but not out in the environment, inside like a truck. Have you seen any machines that build, that can be delivered to a construction site and do on-site manufacturing in a way that would be resilient to weather?
We had talked about this extensively, and Cody was aware of, I think there was a truck where it was a container of some sort was brought down via truck, plopped onto the job site, and there was basically a workstation and repair station ready for kind of prefab components, which is super cool. But on a larger scale, I would agree with you that needs to happen. I don't think it's been done on a large scale or industrial scale at this point. But that has other applications too. You can drive it into, or fly it into remote islands if there's emergency help needed and or emergency construction that needs to take place, particularly on the energy side for electrification as well. That's a contained space where you prefab components or poles or transformers of some sort and kind of just ship them out. And again, I don't know any specific huge examples, but Cody was very excited about that component when talking about prefab and the manufacturing ease of the sort of 10-year, 30-year timeline down the line.
So earlier, Bill was talking about rebar work, and a lot of the forms of steel that you see before you pour concrete involve welding and bending and fastening. I have seen structures set up at a construction site where that rebar work was going on kind of in one area, producing preformed steel, and then that would be lifted into the rest of the building as a subassembly. It seems like that welding area where the rebar could be pre-assembled could be more resilient to weather. And
absolutely. As my experience, there's no, whenever it starts to rain, all the rebar guys go inside. So I would agree that a resilient either shipping container or something that could house the level of rebar work needed in a certain type of construction site, maybe small scale at first, and then expand it to large scale would be a first step in the right direction. Once your rebar gets wet, might be an issue for you.
Yeah, no one likes operating high voltage equipment in the rain. It's frowned upon at most construction sites. So. Right. Any other questions for our weather topic? All right, hearing none. I think we're at the top of the hour. I think we had a good set of questions throughout. Does anybody have any overarching questions that they would like to throw out for the folks that are online? All right, well, seeing none, I would If you could hand the ball back to me, Kathy. All right, I'd just like to say thank you to the Construction Industry Institute for your partnership in this forum today. And I want to thank all the organizers, including Kathy, for helping make this happen, as well as Heather Beal. Stay tuned. We're going to do another one of these at our next big conference, the IROS 2021. We'll have an additional industrial forum there, likely on a new focus topic. If you've got any thoughts on what other industries that we should focus on, please drop me a note, and we'll pick one for the next conference. With that, thank everybody, and have a good day.
Thanks, Rob.
Thanks for having us, Rob.
Thank you.
Thanks for joining, everyone. Enjoy your day.
You too.